All right, hello guys, we are here and we're going to be talking about graphing inequalities. That's something you should have gone over in Algebra 1, graphing normal like inequality lines. Okay, but what's going to be new is absolute value inequalities. Just going over the basics of graphing a line, right? We remember y equals mx plus b. The m and b values are going to determine what this line looks like. So we look at the b value first, and that's going to be the y-intercept, right? That second number, apart from the x, is telling us where this line is going to cross the y-axis. So in this first one, it's -7. So I go down here to -7 on the y-axis, and I make a point there, okay? So that's what the b value tells us, where to begin, I like to call it. And then the m value is the number multiplied by the x, and that is 2 here, okay? So that 2, right, is called the slope, and you might remember the slope, another way to think of it is rise over run. You might be saying, oh, it's not a fraction. And again, if it's not given as a fraction, you make it a fraction by putting it over 1. Okay, so 2 over 1. So I think, okay, rise is the top number. So that's how many spots I move up or down from this starting point. Okay, and then the bottom number is how many spots I move. Usually it's to the right. Okay, so if it's positive 2, that means I'm moving up 2 from this starting point. And then 1 is the run, so I move right 1, right that many spaces. So up 2 and right 1 from that starting point, and I make a new point there. And I keep going. With inequalities, because this is an inequality, right? Usually I would tell my kids, okay, stop graphing. You're good after 3, 4, or 5 points. Okay, but it's actually going to be really helpful here to keep it going the whole time. So you have all these, okay? Why do I need to do that? Why do I need to keep it going the whole time? Because this is not y equals mx plus b, okay? If it was an equation, I would be done. I would just connect the dots. There's my line, I'm done. But this is an inequality, okay? This is saying y is less than or equal to 2x minus 7. So there's 2 extra things I need to worry about with inequalities compared to normal equations, okay? I need to worry about shading, right? If I shading above the line, if it's either of the greater thans, okay? Greater than or equal to. I shade below if it's either of the less thans. And even before I do shading though, I should have gone over this in the reverse order. I need to draw either a dotted or solid line. It's going to be a dotted line if it does not have a line underneath it, okay? And it's going to be a solid line if it does. That's what I say. That's what I tell my Algebra 1 kids. It's going to be a solid line if there's a solid line under your inequality, okay? And if it's dotted, it does not have that. So what is that? Well, let's draw it first, and then I'll talk about what it means. This is less than or equal to, okay? So we're focusing all on this to answer these questions, all right? So less than or equal to, okay? So that is going to be a solid line because it has the solid line under the inequality. So I just connect these dots like normal, and it does go on forever, so we do draw the arrows on the ends. Okay, and then the shading. Am I going to shade above this line or below this line? And it is less than or equal to, and so if it's less than, it's shaded below. And so this is the area that would be shaded in, okay? What does that mean? Well, that means that, okay, any point in this shaded area is going to be a solution, okay, to this inequality. Okay, we'll do one more line, and then we'll get into the new stuff, absolute value inequalities, okay? You might be looking at this like, whoa, what the heck? That's not in slope-intercept form. And you would be right if you said that. Okay, for it to be in slope-intercept form, the y needs to be by itself. And so I look at where my inequality sign is, and what I want to do is get rid of anything else that's on the side with the y. I want to isolate the letter y. Okay, so how do I do that? Well, I'm going to get rid of this positive 2, so I'm minus 2 from both sides. And I'm left with negative y, right? That's still here. Negative y is less than 1/3 x, but I have positive 1, and then I subtract 2 from that, so I'm left with negative 1. But y is not quite by itself yet, okay? This negative is still here. Again, we think of that as negative 1y. So what do I do with a negative 1y? Well, I divide the negative 1, okay, because that's being multiplied. So I divide by negative 1, and then everything over here gets divided by negative 1. And then you remember, what else does that do with inequalities? I divide by a negative on both sides. So that flips the inequality sign from less than to greater than, and then I divide all these by negative 1. And all that does, right, dividing by 1 doesn't change the number. It just, right, when I divide by a negative 1, it's just going to flip the sign. So this was positive 1/3. Now it's negative 1/3 x. And this was negative 1 divided by a negative 1, so that's going to turn it into a plus 1. So y is greater than negative 1/3 x plus 1. That is my inequality now. And it's in the slope-intercept form, so I can graph it. So again, I think, what's my b value? Positive 1. So I go to positive 1 on my y-axis. I make a point there. Okay. And then my slope is negative 1/3. So my rise would be negative 1. So I move down 1. And then my run is 3. So down 1, right 3 point. Down 1, right 3 point. And I'm good there. Again, it might be a habit for you to just connect those dots and be done, okay? But we can't do that yet. Again, we have to answer these extra things, okay? So first, is it a dotted or solid line? Okay, and I look at my inequality sign, not in the original, but again, because it flipped, right? It flipped, so it's important that I look at the one at the very end, okay, of my final equation. Does it have a solid line under the inequality? No, it does not. So that means it is not a solid line, but a dotted line. So you don't make it solid, you make it dotted like that. And so what does that mean? That means that points right on this line are not good solutions to this, okay? And then my shading, I'm going to shade either above the line or below the line, okay? And I look at this, it is greater than. So greater than means I shade above. So all this area right here is shaded in, and that means that any point in the shaded area is a good solution to this. So there you go. There's a little bit of a review, okay? Let me erase these. We'll do some absolute value ones and be done. Alrighty, so 3 and 4. So I have some absolute value inequalities. And it's important that we learn transformations first, okay, right? Because these are going to be inequalities with following those transformation rules, okay? So what's tricky here is we do want to copy on the parent function, right? Because these are all absolute values, so we can just draw that V shape on here. But what I would say is draw it really faint, or just like be prepared to erase it, because there's going to be shading here on this graph, and so we don't want the parent function really shown once I actually draw the actual equation here. So I look at this and I think, okay, how is that different? What extra values does this have compared to the parent function? And x plus 1, okay, in the group here. So plus 1, that would be an h value, and so that would mean I take this and I move it left 1, okay? And again, that's that origin point. I take left 1. And then minus 4 outside of the group, so I move that down 4, okay? So those are the transformations that are happening, okay? So again, the absolute value is one of the simpler parent functions. It's just this V shape, okay? And there's no A value out front here, so that V shape is going to remain the same. It's just going to be shifted down 1, or down, sorry, left 1, down 4, sorry. So if you need this here while you move it, that's fine. But yeah, left 1, down 4 right here. So that's where the actual vertex is going to go. And then I make my shape from there. So I up 1 over 1 to both sides, up 2 over 2 to both sides. And once that shape is drawn, you get rid of this, okay? And again, like before as well, I would recommend drawing points, right? It's going to be that same pattern the whole time. I know for parent functions, we didn't draw any more than 5, but it's just going to be a straight line this whole time up here and this whole time here. So let me draw those. So I've got them all drawn here, and so I look at, for the same things, I look at this inequality sign, and I still answer the same questions as I would with a normal line. I think, okay, is it going to be a dotted or solid line? And do I shade above or below this? Okay, and this is a solid line, because there's a solid line under the inequality. So I connect the dots here. And then do I shade above or below this? Okay, so it still kind of cuts the graph into two pieces, even though it's not a straight line. So we have this region here, and then this region down here. Okay, so which one of those do I shade in? And so if it's less than, I shade below the line, okay, and that's what it is, it's less than. So I shade this underneath region down here. So that's all shaded in, meaning everything on the line and then below it would be a solution to this, okay? So there we go. Last one, number 4, a little trickier, okay? Y is less than -2 times absolute value x plus 3 minus 6. Okay, so again, transformations, what do I got in here? I've got this -2, that's an A value, right? And so that's gonna mean, that negative means vertical flip. So instead of an upwards V, it's gonna be a downwards one, kind of like a capital A almost. And then there's a 2 times multiplier, and that just means a vertical stretch, right? So it's gonna be stretched out, that letter V shape, okay? And then there's also the H and K values. So there's an H value of +3, so that means I move left 3. And then my -6 is the K value, so I move down 6. Lots going on, okay? So let's draw my parent function first, that V shape, But again, draw it kind of small because you're going to be erasing that because it's not going to be included in the final graph. And then, okay, let's do my shifts first. Remember, I shift that origin point this many. Okay, so I shifted left 3, down 6. So that's where my actual origin point is going to be. And then I do these two things, okay? When I was first teaching this with a lot of transformations, you could kind of draw what the original shape would be without an A value here, okay? But it's going to be different than that, okay? Because there's two things. It's a vertical flip, so it's going to be going downwards now, and there's a 2 times multiplier. So the Y value distance is going to double. So instead of moving up 1 and over 1, right, so it would be down 2, right 1 and left 1 to both sides, okay? And then instead of up 2 and right 2 and left 2, it would be down 4 and over 2 to both sides. So once you draw the actual shape, get rid of all your helpful points here that you use to help draw the shape. Right, take into account the inequality sign, and that's going to tell me where the shading is and what type of line it is. So it's less than, just less than, and so that means it is a dotted line, and the shading is below. So thank goodness I don't have to waste all my ink, because I don't have to shade in all this area, just this little pizza slice right here. That area is going to be shaded in, okay? So that very small area of this graph are going to include points that are solutions. Okay, I'm going to do one more with you. I'm going to show you the graph first, and we're going to get the equation from it. All right, so I've got number 5 here. What is the inequality shown below? And I'm given this graph, okay? So we're going to be working backwards. I have the graph this time. Now I want to put together my absolute value inequality, okay? So just, again, what parts do I know are going to be a part of it? I know it's going to be Y. I know there's going to be an inequality sign there where the equal sign normally goes. And I know there's going to be absolute value bars, and there could be an A, an H, and a K value in there. Looking at this, where do I start? Well, again, I always start with the parent function, okay? And you know it's absolute value. So I want to compare, well, how does my absolute value normally, my parent function shape, compare to this? So I look, okay, there's my origin point, and then I compare that to where this vertex is, right? Because it's this vertex. The vertex of this original is right on the origin, and so it's shifted. Here's the new vertex up here. So I count how many spaces did I move to get from here to here. Okay, that's going to tell me my H and K values, right? And so I count, right? It moves up 7, and then it moves left 4. Up 7 and left 4. So what does that mean? Well, that means, right, my K value, my vertical shift was up 7. So that's going to result in a plus 7 outside of the group with the X, okay? And then a left 4 means that it is a X plus 4. That H value in here is going to be a plus 4. How else does it compare to the original, okay? Well, you notice it, instead of opening upwards like a V shape, it opens downwards. These lines are going diagonally down, which means a vertical flip happened. So there's going to be a negative out here. And then what else happens? Well, there is a change in the shape, right? Because normally it goes up 1 over 1, up 2 over 2. Okay. Now it's going down 1, right? And it's going down because of the vertical flip, but down 1 over 2, down 2 over 4. Okay. Why did that happen? Well, that means there was a vertical shrink, we call that, right? It's not a taller V, it is a wider and fatter V. Okay, so that means there's a vertical shrink, okay? And it's not including all the points in here, but we could draw another point here, over 1 and down a half to both sides, and et cetera. We could include all the half points in here as well. But long story short, this was cut in half. The Y value distance was cut in half from what it normally would be, which means there is a 1/2 A value, right? And we said when it's a half or a number less than 1, that is when it shrinks or becomes a fatter and wider shape. Now we're not done. I know that's a lot of work. You might be like, wow, but we still have to deal with the inequality too. And that's just 2 extra questions and then we're done. Dotted or solid line? It is a dotted line, which means what? Well, that means there's not going to be an equal to under my inequality. It's just going to be greater than or less than. And which one of those is it? Well, we look at the shading. Okay, is the shading above the line or below the line? It is above the line, right? Which means it is greater than and not less than. So that is my full inequality. Okay, so there's absolute value inequalities for you. Hope that makes sense. Good job. Thanks for following.